Okay, welcome back Science 30s to our next lesson in organic chemistry. Today is 2.4 and we're looking at carboxylic acids. How a carboxylic acid forms is we oxidize an alcohol. We looked at alcohols in the last lesson, which were based off having that OH or hydroxyl group. Now, how we oxidize it is actually fairly complicated and there's lots of steps, and we don't need to know those for this level of chemistry. So we're going to oversimplify it. And what we're going to do is we're going to get rid of those hydrogens, and then we're going to introduce an oxygen. The oxygen is then going to cause a double bond or have a double bond with that carbon where it used to be bonded to two hydrogens. Now that we have the double bond to oxygen and the OH, we're just going to spread out those bonds here. So we can see the three things that carbon is bonded to. And we see that carbon is bonded to C, O, and then OH. So it's sometimes written as COOH. And this is what defines something as a carboxylic acid. A common example of a carboxylic acid is acetic acid, which has the formula of CH3COOH. You may have seen this example in earlier science courses like Science 10 and 20, as it's often used as an example that is familiar because this is actually the formula for vinegar. That's its common name. And it taught us to recognize that acids aren't always just leading with an H, like HCl, but sometimes they have that COOH at the end. Now you may be thinking, why is that COOH considered an acid? What makes it about that is acidic? Well, we learned before that an acid is a proton donor. So why this likes to give away a proton or an H plus is because the OH here, it can get rid of that hydrogen, and the hydrogen leaves behind its negative electron on the oxygen. So I'm going to put the H as a plus and leave a negative electron on the oxygen. Now that oxygen is keeping that electron, but it could share it with the carbon. So let's draw the electron going to share with the carbon. That's basically what a double bond is when we have already one sharing electron and now we're sharing the other one. So if carbon's now sharing with this oxygen, it doesn't need to share with the other one. Right? We draw that line to show the bond, and then the oxygen is free to go up to that oxygen. It looks very similar to the original oxygen we had here, an O with an electron. Then it bonded to carbon and an electron popped up to the top one. And this can keep going back and forth. So the electron keeps going back and forth from being on one oxygen to being shared and moving like this. This is actually very stable. It's something called resonance, and it's a stable place for that molecule to be in this format. So since it likes to go to this format, I'm kind of personifying a bit that it likes to do this, but because this is stable, it gives up that H plus easily, which makes it a proton donor and classified as an acid. Next, on to naming these carboxylic acids, we'll follow pretty much the same rules as before, except a couple differences, and the main difference is looking at the end or the suffix of our parent chain. It's going to change to oic acid. So for example, if we had pentane and the last carbon there has a OOH bond, that would change to pentanoic acid. Okay, that's going to be a big change. The other part is that the carbon in the carboxylic acid has to be labeled number 1. That's going to take priority for our numbering, so we're going to have that carbon as the first one and number from there. That actually makes it a bit easier, so we don't have to determine which one is going to be the first carbon. Okay, so let's take a look at some examples. This first one here, we have the Lewis diagram. We have the COOH over here, and then a branch of two other carbons connected to it. So I look for the longest branch of our longest chain of carbons, and I see that there are 3. We do include that carbon that's in the carboxylic acid. So we count that one as number 1. It's attached to 2 more. We have a chain of 3. Okay, so I'd label them 1, 2, 3. There's no branches coming off these, so I don't have to worry about naming those. We just know that this is 3 carbons, so this would have been propane, and it turns into propanoic acid. Here, our next example, we have a line diagram. So we can see that carbon has a double bond to O and then a bond to OH. That's our carboxylic acid. Look for the longest chain here. It's 1, 2, 3, 4, 5. So that would be pentane, but we're looking at this as now being pentanoic acid. But we do see that this one has a branch off at the bottom there. So let's put our numbers up. 1, 2, 3, 4, 5. And it looks like our branch, which is a methyl group, because there's 1 carbon coming off of that, is on number 4. So we have 4-methyl, and then we have pentanoic acid. That's going to be 4-methyl pentanoic acid. And for our last example, another line diagram. This one looks kind of flipped upside down, but we still have that carbon double bonded to a O and then bonded to an OH, so it's a carboxylic acid. And then over here now we have a halogen, we have a fluorine or a fluoro branch there. So let's take a look at naming that. Again, find our longest chain. Now this can sometimes be a little tricky because it looks like this line here coming to the fluorine is going to be another carbon. We might think with the line diagram that it would be 5. But the only reason this line's coming here is to get to the fluorine. Okay, so we actually only have the 4 carbons, and this line is just saying that carbon's bonded to the fluorine. So parent chain is just 4. Okay, so that would be butane. And now let's number them. We always start with the carboxylic acid. So 1, 2, 3, 4. So my fluorine or fluoro branch is going to be on number 4. Let's put all that together and call it 4-fluorobutanoic acid. And that's it for this video. I hope that helped you to understand a little bit about what carboxylic acids are without having too much detail, and also how to name them. Thank you so much for watching this video, and I'll see you in the next lesson.